Hey, Global Impact. This is Mr. Ellinger. This lesson is on inequalities and their graphs. So we've spent some time talking about equality and their properties. Let's talk about inequalities a little bit. Our learning target for this lesson is to write, graph, and identify solutions of inequalities. Some essential understanding that we need to have from this lesson. First, an inequality is a mathematical sentence that uses an inequality symbol to compare the values of two expressions. Also, inequalities can be represented with symbols, and the solution of an inequality can be represented on a number line. Some background information for this lesson. An equation such as x equals 7 has only one solution. It can be graphed on a number line as a single point on 7. Remember, a graph is just a visual representation of an equation or problem situation. The solution of the inequality x is greater than 7 are all real numbers greater than 7. This can be graphed on a number line by putting an open dot at 7 and drawing an arrow to the right of 7. The open dot indicates that 7 is not a solution of the inequality, but is the starting point of the graph displaying the other solutions. This set of solutions is an infinite set of numbers. So comparisons in mathematics are done with equality or inequality. Things are either equal to each other or they're not. When done with inequality, two quantities can be related one of the following four ways. We could have two quantities being greater than each other, one greater than the other, so we would use this is a greater than symbol. Two quantities can be less, one can be less than the other. So if one is less than the other, we use this symbol. Greater than or equal to. One quantity can be greater than or equal to another quantity. Finally, less than or equal to. One quantity can be less than or equal to another quantity. One of the things that we need to be able to do, we need to be able to write inequality statements from word phrases. Again, translating words into math is critical. So two examples here. What is an inequality that represents the verbal expression? So in part A here we have the verbal expression, all real numbers p greater than or equal to 1.5. So we're going to put our variable p, our greater than symbol, and 1.5. Okay, from the statement which one is greater, p is greater than. So p is first, p greater than 1.5. You know, a lot of times you maybe have heard, think of the inequality symbols as a gator mouth or a Pac-Man. Okay, if I make a little Pac-Man out of this, hey, there's Pac-Man. Pac-Man's always eating the greater amount. Okay, and the point of this is that I could take this inequality statement, I could flip the two, I could put 1.5 on the left and put p on the right. As long as my inequality symbol is going the other direction, I still have a true statement. 1.5 is less than p is the same as saying p is greater than 1.5. Okay, and if I use my Pac-Man reference or my gator mouth reference, Pac-Man is still eating p, which is the bigger value. So my second example here, the sum of t and 7 is less than negative 3. So here we have a sum, t and 7. So that means t plus 7. And they say that sum is less than negative 3. So that's how we would write that. The solution of an inequality is any number that makes the inequality true. The solutions of the inequality x is less than 5 are all real numbers x that are less than 5. So if you think about how many real numbers there are that are less than 5, there's a bunch. You can evaluate an expression to determine whether a value is a solution of an inequality. You can use a graph to indicate all of the solutions of an inequality. So here we have some examples. First, we have the inequality n is less than 1. On our number line, here's 1. We have an open dot or a circle at 1 and an arrow going to the left. Remember, on a number line, if we're at 1, everything less than 1 is to the left, everything greater than is to the right. So since this is n less than 1, we want everything to the left of 1 to be on our graph, if you will. So we have the number line, but the actual graph is what's in red. The open dot shows that 1 is not a solution. We shade or draw an arrow to the left of 1. So think of the open dot as a hole. There's a hole at 1. There's a hole in the graph. Everything on this red graph is a solution to n is less than 1, but we put a hole here at 1 because 1 is not actually less than 1, but it's kind of like the starting point of the graph. Everything to the left of 1, everything to the left of 1, or everything less than 1 is a solution to this inequality. Here we have another example, a greater than or equal to 0. On our number line, we would put a dot on 0, closed dot, because 0 is greater than or equal to 0, so 0 can be a part of the graph. And then everything to the right of 0 is greater than 0. So again, the closed dot tells us that the end point of that line, or the starting point of that line, depending on how you want to look at it, is in fact a solution to the inequality. Right, another example, f greater than -3, just greater than, not equal to, so we'll put an open dot on -3, and then everything to the right is greater than -3. -2 greater than or equal to x. Same thing as saying x is less than or equal to -2. So since it's equal to, we'll put a closed dot. Less than is everything to the left. Now, question, what does the graph of an equation look like? And I kind of mentioned this just a few moments ago in the lesson, but let's say we had the equation x equals 2. And let's say that here is 0 on a number line. Okay, here's 1, and here's 2. We want to visually display the solutions to this equation. X equals 2. 2 equals 2. Are there any other values that equal 2? Well, the answer is no. There's only one value that equals 2. So the graph of an equation is kind of boring. It's just a single dot, and it's a single dot wherever x, or whatever our variable is, equals that value. So x equals 2, dot on 2. So there's an infinite number of solutions to an inequality. There's only one solution to an equation for now. Another thing we need to be able to do is we need to be able to take the graph of an inequality and just write the inequality that represents the graph. So in part A here, we have a graph, we have a dot on -3, so we know our inequality is going to involve -3. We have an open dot, so we know that's just going to be a less than or a greater than. The graph goes to the left, so we know that's a less than. So if we want to use our x as our variable, we know that x is going to be less than -3. Everything to the left of -3, not including -3. And a word we use, inclusive. Okay, this is x less than -3, not including -3. Our second example here, we have a closed dot on 0 and an arrow to the right, so we know that that means x greater than or equal to 0. Or x greater than 0 inclusive, meaning including 0. That's another way to say this. X greater than or equal to 0, or x greater than 0 inclusive, including 0. Okay, so and this box just kind of summarizes things. It kind of makes the connection between words, symbols, and the graph. So you can pause and take a look at those if you'd like. Hope you guys have a great day.